We're going to take a close look at some tools that can improve system resource management so you don't have to worry about running out of RAM or having Macs crash when you render very large scenes. The first part of what I'll be covering is not specific to VRay, but because the concepts are so fundamentally important whenever you work in Macs, it's really worthy of a discussion here about the subject of resource management. And after this, we'll look at some other great VRay features that didn't find a place in other modules. These features signify the last of what I believe to be the important VRay features that need to be presented in a course geared towards architectural visualization. In Module 9, we'll put these tools to the test by lighting an exterior scene and an interior scene from scratch using everything we learned in previous modules. So let's begin this discussion with an in-depth look at some tools that allow us to better manage our system resources. In this scene, I have a single tree by itself, and this tree was actually created by a plugin called Onyx Storm, which is a great plugin I use on virtually every exterior scene to quickly and easily create realistic 3D trees. Now the thing I want to point out is that this tree is parametric based, which means that its structure, i.e. all the branches and leaves, etc., is controlled and generated through parameters. So Max doesn't have to store the information for each individual leaf on this tree because the size, shape, and orientation of all the leaves are really derived from algorithms. And the same concept applies to a primitive object like a teapot. So if you want to change the smoothness of a teapot, simply increase the segments parameter. And this type of object is completely different from the edit mesh or edit poly objects, whose structure and display are based on sub-object components like vertices and faces. If I were to collapse the teapot to an editable mesh, then the teapot is no longer parametric based, and a lot more information would need to be stored for this object. And in fact, all of the individual sub-objects, faces and vertices, needs to have a position, rotation, and scale value defined, and this simply means a much larger file size being generated. Now for the next few minutes, I'll be working with this particular tree, which is an Onyx tree and something I'm not authorized to distribute. But if you want to follow along with this exercise, simply create a teapot with 64 segments and use the same steps. A teapot with 64 segments contains 262,000 faces, which is almost identical to the tree I'm working with here. So for all practical purposes, you would get identical results in terms of resource management. So in the case of the tree shown here, what I want to do is save this file to the hard drive while it's still in parametric form. And I'll call this file one Onyx tree and save it to an empty folder. When this is done, if I press the keyboard shortcut 7, I'm shown the scene face count and vertex count in the active viewport. But I can also go to the viewport configuration menu, and in the statics tab I can enable the total plus selection option, which allows me to see the face and vertex count of individual objects that are selected, not just the entire scene. So with just this one tree, the face count is 267,000 faces, which is quite large for an individual object and quite large even for a tree. But if I look at the file that I just saved, notice that the file size is less than 400 kilobytes, which is really not quite large at all, especially when you consider that an empty scene is going to generate a file size of about 150 kilobytes anyway. Now before I go any farther, I want to open the Windows Task Manager and keep this Windows Task Manager open for the remainder of the discussion on system resource management. And with it open, I see several different tabs, one of which displays 3 very important values that you really should always keep an eye on when you're working on large resource-hungry scenes. And they are processor usage, the page file, and available RAM. With the Task Manager open, I want to right-click inside the active viewport and collapse the tree to an editable mesh. And save this file again, this time with the name one tree collapsed. Now if I go to the save folder and look again at the file size of this scene, I can see that the file size is now over 21 megabytes in size. And the reason that this scene generates such a large file size is because Max can no longer define the tree structure by algorithms or formulas. Instead, it has to store the X, Y, and Z value of every single individual vertex and face and all the other sub-objects for each of the three transform types: position, rotation, and scale. So for an object with 267,000 faces, it's pretty easy to understand why the file size is 21 megabytes. Now for the next demonstration, I need to make 15 duplicates of this tree and place them in a 4x4 grid. Since this tree has so many faces, displaying it in its entirety is really a strain on the graphics card, so what I should do before making duplicates of an object of this size or this complexity is to turn the object into a box. So in the display panel, I simply select the display as box option, and working in viewports will be much easier when I do this. When I make the duplicates, I want to make sure that they're created as instances rather than copies, so that they don't increase the file size. And I can see, in fact, with 16 trees total, when I save the scene, I'll give it the name 16 trees instance. When I save the scene, I can see that the file size has barely increased. When I select one individual tree, notice that the Edit Mesh modifier is shown in bold, indicating that it's an instance. This object is an instance of another object. Well, now I want to select all the trees and collapse them into editable meshes, which would make them unique, which would make them not instance to each other. And when I do this, notice that the available RAM drops by about 400 megabytes. I'll save this file again and give it the name 16 trees collapsed. And notice that when the file is saved, I once again get a big drop in available RAM. And this happens when you save large files like this. But once the file is finished saving, you'll see that the available RAM returns to what it was before the save. And this is going to take a few moments, so I'll pause the video. And now the file is finished saving. So returning to the save folder, notice that the file size is now over 340 megabytes, which is the reason why it consumed so much RAM when the trees were collapsed, and also why it took so long to save. Now before I render this out, I want to demonstrate one more thing that concerns RAM. What I want to do is attach a few of the trees together and see how that affects the available RAM. So with one tree highlighted, I'll go to the Edit Mesh modifier in the command panel, and using the Attach List command in the Edit Mesh modifier, I'll select a few of the trees from the Select Objects dialog box. But before I click OK to complete the attach command, notice my available RAM, and now when I click on OK, you can see that the RAM takes a nosedive. Now that attach command that I just executed was extremely memory hungry because essentially Max has to store the original version of the trees as individual objects, and also an additional version with some of the objects attached together. So if I were to repeat this command by adding more trees together, more RAM would be consumed, and before long Max would almost certainly crash. So if I were to start rendering this right now, I would really be doing myself a disservice because I'm giving VRay much less memory to work with. So I should instead free up this memory that was consumed with the attach command and then render the scene. If I right-click the undo icon, I'm presented with the last 20 steps that I conducted in Max, and of course I can go back to an earlier step before the trees were attached together. But this won't free up any memory because the attach command that I just executed would only be moved to the redo list, and it wouldn't change the amount of RAM available. So to free up this memory, I could reset Max and load the scene again, but since the scene file size is so large, this will take longer than I really want to wait. So instead, all I need to do is create an object and change a parameter or two several times until that one memory-hungry heavy attach command is purged from the undo list. So I'll create a sphere and change the radius several times, and as I change it, notice in the undo drop-down list the Convert to Editable Mesh step keeps getting pushed farther down in the list. I'll change it some more and check the undo list again, and now the step is just about to be purged. So keep watching the available RAM as I make a few more changes to the sphere. And there it goes. The RAM is returned close to what it was before the trees were attached. So this was just a demonstration to point out why you should always keep a close watch on your system resources and why you should always clean your RAM prior to rendering. Now I want to render this scene using the same trees before the attach command was executed, while these trees were still individual objects. While keeping an eye on the available RAM, I'll just go ahead and click on render, and as you can see, the RAM bottoms out, and eventually I get a crash. I'll pause the video while I load the scene again, and now I want to render the scene again, making one minor change to a render setting, and this one setting change will allow VRay to render the scene again without crashing. That setting is found in the VRay system rollout, and it's the drop-down list called default geometry. This setting determines whether objects in a scene are going to be rendered as static geometry or dynamic geometry, and the difference between the two options is really immense. In a nutshell, VRay gathers a lot of information about objects in a scene, and it performs an immense number of calculations based on the information it gathers. When objects are treated as static geometry, the information it gathers is kept in RAM until the entire rendering process has been completed. And for large scenes, this can often result in max crashing, as it did here. When objects are treated as dynamic geometry, the information VRay gathers is continuously compiled, used, and then discarded. And this allows you to render very large scenes without running out of RAM. The downside to using dynamic geometry is that it can cause a significant increase in render times because all the time that VRay spends transferring information from hard drive to RAM and vice versa. But nonetheless, it's really often the only way you're going to be able to render very large scenes without running out of RAM, and when it's needed, it becomes an invaluable feature. So if I render the scene again in dynamic mode, it will have no problem completing the rendering, and in fact, the amount of available RAM changes very little during the rendering process. Okay, well, certain object types are considered dynamic geometry regardless of which mode you render in. Examples of these are VRay proxies, VRay displacement mapped objects, and objects rendered with the VRay Fur feature. These types of objects are automatically treated as dynamic geometry, which is a good thing because if they were treated as static geometry, they would be drastically less useful, and VRay probably wouldn't even be able to render some scenes without running out of RAM. So when you set the mode to static, these memory-hungry object types are going to be allocated a certain portion of the available RAM, and that amount of RAM that's allocated is specified by the dynamic memory limit value. By default, it's set to 400 megabytes, and this is often plenty of RAM to render dynamic objects in your scene, but oftentimes it's not. So let's look at an example scene where this size value really becomes important. In this scene, I have several buildings, some 3D terrain, a bunch of 2D trees in the background, and dozens of high-poly 3D trees in the form of VRay proxies. I kept this rendered image size fairly small to make the rendering finish quicker, but the point is, when I render the scene using the static geometry option with 600 megabytes of dynamic memory, my rendering time is 3 minutes and 59 seconds. Now if I decrease the dynamic memory limit to 400 megabytes, which is the default value, when I render again, you can see my rendering time is basically the same. Now at 300 megabytes, the rendering time is still the same, but if I reduce it to 200 megabytes, the rendering times increases significantly. And the reason it increased is because 200 megabytes is not enough memory to store all the information for all the proxies in the scene. Between all the different types of proxy trees in the scene, I have more than 200 megabytes in file size, but less than 300 megabytes. So if I have one 3D oak tree whose proxy file size was, say, 75 megabytes, a palm tree whose proxy file was 60 megabytes, and say a crepe myrtle whose file was 80 megabytes, together that would be 215 megabytes, and that would be the minimum you would need to allocate for such a scene. This scene actually contains a few more tree types, and together their file sizes equal less than 300 megabytes, But the point is, make sure you understand how to set this value properly. Too high or too low of a value could add a tremendous amount of rendering time. And to show you what the same scene looks like when rendered with dynamic memory, it results in more than a tripling in rendering time. Again, I don't have to worry about running out of RAM when I use this option, which is certainly a great thing, but it should only be used if you can't render in static mode with the amount of RAM that you have available, because if you do render in dynamic memory, then it's almost certainly going to increase your rendering time, sometimes as much as you see here, 3 times as much. Now let's look closer at exactly what a VRay proxy is, and it's one of my absolute favorite features in VRay, and I would recommend using VRay to users that don't know anything about it, if for no other reason than this one feature alone, because with this one feature you could literally render immense scenes with almost a limitless number of faces. A VRay proxy is a little bit like an external reference. It's simply a placeholder for a real object whose structure is defined by the data in a separate file known as a VRay mesh file, and that file has the extension .vr mesh. The data required to store a proxy, i.e. the placeholder, is virtually nil, and you could therefore have thousands of these proxy objects in your scene. To create a proxy, simply select the object you want to turn into a proxy, right-click the object in the active viewport, and select VRay Mesh Exporter. In the dialog box that opens, specify a save location, give the proxy a file name, choose export as single file or multiple files, and whether or not you want to have the VRay proxy created automatically or not have it created. By choosing the export as a single file option, you're telling VRay that regardless of how many objects you have selected when you start the VRay proxy command, you want all the objects to be saved together as one proxy file. Exporting to multiple files simply means that each individual object will be saved to an individual file. Which one you choose is fairly important. So if, for example, you have 10 3D trees and they were all the same instance tree, it wouldn't make sense to create 10 separate proxy files of the same object, nor would it make sense to create one proxy file of all 10 objects. What you should do in this case is create one proxy object and then duplicate that proxy, replacing all the instances with that VRay proxy. So for the 3D tree I just created earlier, what I should do is go to the Create panel, select the geometry icon, click on the drop-down list, and select VRay from the list, and click the VRay proxy button. I can now click the Browse button, find the proxy file that I created, and click in one of the viewports to actually place the proxy. I can choose whether to display the proxy as a bounding box or as a preview from file. Working with a bounding box, of course, can make viewport navigation and screen refreshes much easier. Well, now that I have this proxy loaded into this file, I can simply duplicate it everywhere I need to. But when you duplicate a proxy, you have to do it as an instance. If you create a copy, the copy disappears. So here, all I need to do is make 9 instances of the proxy and position them where the original 3D trees are. And I don't need to do it for everything here. Once I'm finished placing the proxies, I could just delete the original 3D trees and I'm set. Now when I save this file and look at the save folder, the file size will be very small because all the information about the tree is stored in the proxy file, and all I have in the scene is a bunch of placeholders. But going back to the original 3D trees, I could have also just chosen the Create Proxies Automatically option. And what this does is replace the original object with the proxy object so that you don't have to load it manually like I did just a moment ago. And this is the easiest way to create and place a VRay proxy in your scene. I also mentioned a moment ago that you can decide whether or not to export the objects as individual proxies or one single proxy. I showed an example of when and why you should save to a single individual file. So now let me point out an example when you might want to save as multiple files. Here I have several 3D cars, and if I select all these cars and save them as individual proxy files, I can apply transforms to each proxy individually. So I can move, rotate, and scale any of these proxies separately from each other. And being able to move, rotate, and scale these proxies individually is often necessary and something I couldn't do if I exported them as one single proxy. Because when I load the proxies, all the cars would be locked in as one object. Not only that, the materials of the cars would be altered in an undesirable way because you can't create a single proxy file of multiple objects if those objects have different materials. If you do, only one of the materials will survive and all the objects will get that same material. This is an important point and I want to make sure it's understood, so to demonstrate I'll use this simple scene of 4 teapots. In the scene I have 4 teapots but only 2 objects and 2 materials. As you can see, each teapot is assigned a multi-sub-object material. Now if I select both objects and create a single proxy file out of both objects, you can see that both objects get the same color assigned to them, which is an indication that they're sharing the same material. And now if I use the eyedropper to load the material into a sample slot, you can see that this is in fact the case. So one of the objects lost its material, and when rendered you would see just this one material. What I should have done here is use the export as multiple files option, and that would have created 2 proxy files and preserved both sub-object materials. I want to make a couple more points about proxies before moving on. Going back to the example with the 3D cars, the cars I used are part of a collection by Dosh Design, and here's a directory that contains the 2006 set of Dosh cars and all the directories that come with the collection. Notice also these 2 different files here, Dosh cars and Dosh cars collapsed. I made these files, and what I did from the start, knowing that I would want to use these cars often and be able to merge them into various scenes quickly, I created one file that contains all the cars in their original form, which is as groups, so that I can make modifications to them as necessary. And I created another file with all the same cars, but this time collapsed. Every car was collapsed as one individual object. And I did this because if I choose to turn these cars into proxies, which I would probably always want to do because their file sizes are so large, then I could save myself the trouble of having to attach all the car parts together whenever I want to create a proxy. So here in the file called Dosh Cars Collapsed, I have all the same cars, but now instead of the cars being groups of many small objects, each car is one single object with a multi-sub-object material applied. And now when I merge one of these cars in, it's immediately ready for export as a proxy. And by the way, when you attach objects to each other that have different materials applied, a multi-sub-object material is created automatically. So I didn't have to do it manually here when I attached all the car objects together. As a final note on proxies, you can create them from most any geometry. You could even take a complex building, attach all the parts together as one object, and then turn that building into a proxy file by itself. Again, you could avoid the attach process by exporting all the objects as separate files, but I really recommend avoiding this because it can become difficult to manage such a large group of files, especially when you share the files with others that will be working on the same project. Well, the next feature I want to talk about is the VRay displacement modifier. This is really a remarkable feature, and what it does simply is displace geometry using a map. But unlike a regular 3ds Max displacement modifier, the VRay version doesn't require all the extra vertices and all the extra faces to allow the geometry to be displaced. As an example, here's a simple 10 foot by 10 foot plane with the default 4x4 segments, and as you can see, I've placed a 3ds Max displace modifier in the modifier stack, and I use a noise map with default settings as the source for the displacement. I'm going to assign a strength value of 3 feet to the displacement, and in the viewport you can see the displacement take place, or at least try. The vertices that I have are displaced, but the problem is there's just not enough vertices to allow for a smooth surface when the displacement is applied. I could of course go to the source and add segments to the original plane, or I could subdivide the plane using the subdivide modifier if the object was no longer parametric face like this particular object, the plane object. But doing this adds faces to my scene, which of course increases file size and rendering times, not to mention the fact that it slows the screen refresh rates. To get a smooth look to my plane using the 3ds Max Displace modifier, I need a lot of faces, and when I add faces I certainly get a smooth appearance, but with the VRay displacement modifier you don't have to worry about adding these extra faces. So I'll turn off this modifier and return the plane to a 4x4 grid of segments. Go to the modifier drop-down list and add the VRay displacement modifier. And I want to use the same noise map that I use with the 3ds Max Displace modifier, and I do this to ensure I'm comparing apples to apples. I also want to use the same amount of displacement, 3 feet, but notice in the viewport the vertices aren't displaced. However, when I render, not only are the vertices displaced, the surface is smooth, as if it contained far more vertices than it really does. This is a tremendous advantage to using the VRay displacement modifier. Now let's look at an example where this feature really shines, which is in the simulation of 3D grass. I'm going to stay in the scene, which, if you want to follow along with, is entitled grass.max. In the material editor, I've preloaded some materials, one of which contains a really nice bitmap for the grass, and I want to simply add this material to the plane. Now, for the texture map slot in the VRay displacement modifier, I'm going to use this black and white bitmap which tells VRay the areas that need to be recessed and the areas that need to be raised. With grass, you want to stay with a displacement amount somewhere in the neighborhood of 4 to 6 inches. So I'll try 5 inches here, and when I render the scene, this is what I get. A really nice and quite realistic looking grass. Notice that it did take some time to render this, but in my opinion it's well worth the wait. One of the great things about using the VRay displacement modifier like this is the look that you get when a grass object butts up against another object such as a road or a curb, and where it does join, the two objects won't appear to have a straight, unrealistic line. It will be more of a jagged line like the one shown here in this image. And another important consideration when using displacement, at least for something like grass, since it does increase render times, make sure you use it only where you need it. In other words, for areas in the background of a scene, like the small area of grass back behind the building here, there's no point using displacement when the object is too far away from the camera for the viewer to tell. I cropped this particular image when I created it, but if I allowed more of the grass in the background to show, it would be really quite obvious that no one could tell if this grass was mapped or if it was displaced, like the grass that you see here in the foreground. So make sure you separate your objects and apply displacement to the objects in the foreground when necessary, and not to objects in the background. And make sure you use displacement where it's really needed, i.e. don't add displacement to something like a brick wall unless the brick wall is close enough to justify it. Use displacement wisely or it will increase your render times unnecessarily. A few more points about the VRay displacement modifier. There's a 2D and 3D mapping option, and the results are often similar in terms of quality and render times, but there are some differences. First, 2D mapping cannot use procedural maps. Procedural maps are also known as 3D maps, which can kind of be an aid to remember that they have to be used with 3D mapping. So in this scene, if I take away the bitmap in the texture slot and replace it with a noise map, I cannot use 2D mapping because the noise map is a procedural map, a 3D map. A procedural map is designated with a green parallelogram icon in the material map browser. So if I render with the 3D mapping, it renders just fine. With 2D mapping, there's no displacement. And just to show how similar the two mapping types can be, I'm going to load a bitmap that I regularly use as a bump map to represent stucco on walls, and when I render using 2D mapping, this is what I get. And I'll load this image into the RAM player so that I can compare results with 3D mapping. And now I'll switch to 3D mapping and render the scene again, And when I do, this is what I get. When I load this image now into the RAM player and compare both mapping types side by side, you can see that the results are nearly identical. Also, 2D mapping is best suited for large flat areas of displacement, while 3D mapping works best on smaller areas of geometry that already has some amount of relief to it, some 3D terrain to it. One problem you might find when you use the VRay displacement modifier for animations is flickering. This is because of the often high contrast of pixels that usually comes when you use displacement. When using displacements for animations, you might want to pay a little extra attention or a little more consideration to the anti-aliasing filter you use, and you might have to resort to using a more blurry filter than you would normally use, such as the soften filter. Another great way to create the appearance of 3D grass is with the use of the VRay Fur feature. And as the name implies, it's a great choice for creating hair or fur on characters, but I personally only found an efficient use for this feature on two specific object types, shag rugs and grass. And although its practicality is fairly limited with these two particular object types, it's quite handy. Here's an example of the VRay Fur used on grass, which I probably made a bit too long for this image, but it nonetheless demonstrates its use pretty well. VRay Fur is really as simple as any feature in VRay, and to use it, simply select an object, choose VRay from the Geometry drop-down window, and click the VRay Fur button. Fur is automatically applied to the object, and with the parameters in the command panel, you can control the length, the thickness, curvature, density, as well as many other things. If you use this feature, I recommend applying the same material to the fur object as you do to the object below it. And you always want to make sure you have an object below it, otherwise you'll see the background or some other object that you shouldn't really see. With a nice shadow casting light, you can easily create some realistic grass. And just remember that, like the VRay displacement modifier, this feature will definitely increase your render time, so use it wisely in areas that you can really benefit from it. Now I want to talk for a moment about a nice feature that can really improve the look of any material in your scene, and that would be the VRay blend material. This material is a lot like the shellac material in 3ds Max because it basically superimposes one or more materials on top of another. For the purpose of this demonstration, I'll use a grass material and a couple other ground materials blended together to show how effective this feature can be. So when you place the blend material in a sample slot, you see a base material and several different coat materials. I'm going to start by placing my typical grass material in the base material slot, which is nothing more than a nice image in the diffuse channel of the grass material. And now I'm going to add a coating layer onto the base material, and for this I'll use a mulch material, which I also created just by adding a bitmap to the diffuse channel. So I'll drag this material to the first coat material channel, and as you can see in the sample slot, the two materials are blended together. Now the strength of the coat materials are controlled by either the color swatch to the right of the material or the map strength percentage field if a map is used to control the strength of the coat material. When the color swatch is set to pure white, the coat material is at 100% strength and nothing but the top coat material will show. If I use a color of pure black, the coat material will essentially be completely transparent and the only thing that will be shown is the base material. Now I'm going to apply a second coat material by dragging a material from another sample slot into the second coat material channel. And once again, when I do, I can control the strength through the color swatch. This time I'll set it to gray so that it's about 50% transparent. I'll do the same for the first coat material, and now when I render, I'll see all three materials blended together. Now this doesn't look all that great because applying a mixture of more than one material to the same area everywhere on an object just doesn't look realistic or natural. But what I can do to improve the look here is apply a map to certain areas so that certain areas of the object show different strengths of the different materials. One of the best maps to do this with is the noise map. So I'll add the noise map to the first coat material and change the color swatch on the second noise map to pure black so that I can see the just the base and first coat materials blended together. Of course, through the noise map settings, I can control the size of the black and white areas, which I can see if I enable the show map and viewport option. To make the blend more realistic, I'll use the turbulent option with the levels value set to 1.0, which makes the transition from white areas to black areas much sharper. And this will look much more real than if the transition were more blurred. I also want to double the size value, and that would make the areas of the blending areas a little bit larger on this object. So when I render, this is what I get: a decent blend between the two materials. Finally, I'll copy the noise map from the first coat material to the second, but I want to change the phase of the second noise map so that both maps don't align together to show the black and white areas in the same place, because that just wouldn't look realistic at all. So after shifting the phase of the second noise map and rendering again, this is what I get. And this is just what I'm looking for. So definitely start using the blend material as much as you can to really add depth and variety to your materials. One more material I want to demonstrate in this module is the VRay override material. This is really a remarkable feature, and I'll show you why. Here's a simple scene, and in the scene I have a red sphere, a 100% reflective box behind the sphere, and a 100% refractive box in front of the sphere. Now watch what happens when I render. I'm getting blue to reflect off the sphere onto the floor instead of red, and I'm getting yellow to reflect instead of red, and I'm getting green to refract instead of red. So how did I do this? Well, I did it with a VRay override material. So let's first look at why we get blue reflection instead of red on this red sphere. What we see in the override material is a base material, which is nothing more than a red diffuse color, and a GI material, which is nothing more than a blue diffuse color. So the GI material replaced the reflection, the red reflection color of the base material, and caused VRay to reflect its appearance in the form of bounced light. If you load a map, the colors in the map will be reflected instead of the base material also. This is a wonderful way to control the amount of color and bounce light in the scene, and in a moment we'll look at a more practical application of this particular procedure. The different reflection and refraction materials are pretty straightforward. Just like the GI material, they simply replaced what gets reflected and what gets refracted from the base material. So instead of using the reflection and refraction controls in the environment rollout, which would affect all the materials all at once, use the override material to override what gets reflected and what gets refracted in individual objects. Now let's look at this same scene that we saw in Module 6. When I render this scene, you'll notice that the color of the walls gets reflected off all the surfaces in the scene, and probably more than it should. The floor and the ceiling, for example, are white, yet in the rendering they appear to be anything but white because so much color from the walls is bleeding onto them. If you don't want so much color to be bounced around onto the floor and the ceiling like this, simply make the wall material an override material using the same material as the base, but a much more toned down version of the base color as the GI material. I could in fact use a white material as the GI material, but here I'll simply tone down the GI by reducing the diffuse color of the GI material. Now when I render, this is what I get. A rendering with much less brown bleeding onto the other objects in the scene. And this is a much better way to tone down a specific object like the walls than it would be to use the receive or generate GI option in an object's VRay properties window. If I were to use the generate GI amount in the VRay properties of this wall, I would in fact get less bounce color, but the color wouldn't change, just the intensity. Not only that, I'd get a significant reduction in the overall illumination in the scene, because anytime you reduce the amount of light bouncing off an object, which you would do by reducing the generate GI option, you reduce the amount of illumination in your scene. So the override material is a far better option for reducing color bleed on an object. One more material related feature I want to point out is the VRay dirt map. This is a simple way to add some realism to your scene with the use of a little dirt. When a material is too clean looking, it's usually too unrealistic. So if you add the dirt to the diffuse channel of a material, you can get VRay to place dirt based on the variation in the normals of adjacent faces. If you apply such a material to a flat plane object like the one shown here, when rendered, no dirt appears. But now if I add some variation to the physical surface by moving individual vertices, or as I'm going to do here by adding the noise modifier, when I render I get dirt to actually collect in the crevices just like it would in real life. Dirt would collect anytime you push or pull vertices, or anytime objects that have the dirt map applied to it are joining other objects or other surfaces. And now you would probably never want to use the dirt map in the diffuse color of a material by itself, but if you use it as a coat for a blend material like we just looked at before, you can keep the same base look to your material, but you'd have the added look of a little bit of dirt, and that would add to the realism in your scene. The last feature I want to highlight in this module, and perhaps the simplest of all features to use in VRay, is the VRay Tune feature. It's found in the Environment Effects dialog box under the Atmospheric Effects section. When you add this effect to your scene and render, open edges of your objects receive an outline to them, which is black by default, but you can change this color, and you can also change the line thickness as well as numerous other settings that you find here. And some architects really like the look of the VRay Tune rendering, so I've mentioned it here because you should really consider using it if you've never tried it before. Well, that does it for Module 8. As always, let's take a moment to review what was covered. First of all, when you work in 3D, good system resource management is as necessary as any 3ds Max or VRay skill. If you don't follow some basic guidelines, you can make things very hard on you and your computer. I was originally going to put system resource management in the first module because one could argue it's the most important and fundamental skill for anyone working in 3D. However, most of the features that I presented here that dealt with system resource management really wouldn't have been appropriate for Module 1. Also, I minimized the complexity of the example scenes to facilitate understanding and to speed up the rendering of the scenes, so it wasn't so critical to the examples in this course. In Module 9, you'll see just how important good resource management is when we look at some complex scenes that really put a strain on the computer and VRay. So always keep an eye on the task manager, especially the available RAM. Never set a rendering in motion if you have a large amount of unpurged RAM. If you're about to execute a command that you think might be too much for VRay to handle, remember to save your scene first. And I didn't mention it, and this is a 3ds Max issue, not a VRay issue, but if 3ds Max ever crashes and you're asked if you want to save your file first, I highly recommend going to Windows Explorer, finding the file that it's going to try to save, and make a copy of that file before you click the button to answer yes, because Max will often corrupt the file in an attempt to save it, and if the file becomes corrupt, you might lose more work than just the work since your last save. Whenever you make duplicates of high poly objects, always use the instance method. However, understand that attaching objects with similar materials is a good practice to get into because an excessive number of objects can drastically increase your rendering times, especially during the preparing objects phase. When I create a scene, for example, I have all my curbs collapsed and attached together as one object. I have all my sidewalks attached together, all my window frames, all my walls of similar materials, and so on. Doing so reduces the amount of overhead Max and VRay has to spend preparing objects for render, not to mention it really makes object management much easier. Only objects I don't recommend attaching are those that have a very high poly count, in which case the instance method would be a good choice. But an even better choice than the instance method would be the VRay proxy method, because unlike an instance object, the proxy object is dynamic geometry, which means its memory, the memory that it uses, is continuously recycled, and it's not as large of a burden on your system. Remember that proxies must be instanced if you want to duplicate them, and you can't create a proxy from a group, and you can't create a single file, a single proxy file from more than one object. The VRay displacement modifier is a great feature that can do for the realism in your scene as much as any other feature. It's dynamic geometry, so even though it can add some render time to your scene, it at least isn't as much of a burden to your RAM. It's difficult to create animations with this modifier without the effect of flickering, so always test a small portion of your screen prior to rendering a long animation. And speaking of dynamic geometry, figure out what the optimal dynamic memory limit value is and use that value. Too high or too low of a value can drastically increase your render times. The blend material should be used whenever possible to break up the tiling of materials in your scene, and it's a great feature that just adds depth and realism in general to your materials. The override material is the best way to control the bouncing of light off specific objects. Specifically, I mean the color bleed. Many times VRay generates too much color bleed, and too much can be unrealistic. This is a far better option than using the generate and receive GI options in an object's VRay properties window. The remaining features we looked at, VRay Dirt and VRay Tune, are very simple to use and just a couple of nice tools to keep in your bag of tricks should the need arise. And with that, I'll close Module 8.